Tesla versus Waymo, two opposite document, group. You are currently formulas versus end-to-end, how to pick and for. You are currently link, robotics, July 21st, 2023. In 2018, TV producer Jon Favreau, known for his role as Happy in the movie Iron Man, embarked on an ambitious project to produce the highly anticipated TV show, The Mandalorian, set to premiere on Disney+. Everything was supposed to go smoothly, until the team encountered a significant issue on day one of visual production. Indeed, they realized that the Mandalorian will be wearing a Beskar armor, which contains a high level of reflections. Therefore, shooting the movie using green screens, which were the de facto technique in filmmaking, would compromise realism, and show green reflections everywhere on the helmet. This setback prompted Favreau and his team to seek an alternative solution, virtual sets, circular rooms where every wall and ceiling is made of a rotating LED screen. This innovative approach not only ensures that the projected scene contained the true colors and reflections but also proved to be a cost-effective and actor-friendly solution. The virtual set of The Mandalorian provides a better immersion, lightning, and sets a new path to filmmaking. The virtual set of The Mandalorian provides a better immersion, lightning, and sets a new path to filmmaking. With the implementation of virtual sets, Favreau and his team created one of the best TV shows in the Star Wars universe, and popularized a new production technique that would be reused in other shows like Obi-Wan Kenobi. Today, it's said that LED screens are going to replace green screens in filmmaking. They provide a better immersion for the actors, but also give better lighting, realism, while being significantly cheaper. Self-driving cars are very similar to filmmaking. They have the very traditional and universally approved green screen technique. I call it the four-pillar architecture, and a relatively new and LED screen type of architecture called end-to-end. Over the years, we've seen companies debating over which architecture should be used, some claiming that end-to-end could replace the four-pillar architectures. In this article, I'm going to describe the two ways of building an autonomous vehicle system architecture, and give my opinion on the future of self-driving car software. Heading level 2, the four pillars of self-driving cars. If you have taken my course, link, the self-driving car engineer system. Probably you know that this course introduces you to one type of architecture I call the four pillars. Companies debating over which architecture should be used. Some call the four pillars architecture. Figure. You are currently in a figure. I'm going to describe the two ways of building an autonomous vehicle system architecture, and give my opinion on the future of self-driving car software. Heading level 2, the four pillars of self-driving architecture. If you have taken my course, pillars architecture, so it's all very linear, and we have the output of one being the input of the next one. This architecture is probably the most universally known, accepted, and used for an autonomous driving system. The four pillars are: list 4 items, bullet perception. We use a set of vehicle sensors, such as cameras, lidars, radars, ultrasonics, and more, and we perceive the world. Bullet localization. We take the output of perception, a GPS, and a map, and localize ourselves in the world. Bullet planning. From the obstacles around, and from our position, we plan a trajectory from A to B. Bullet control. Using the trajectory information, and the vehicle parameters, weight, tire size, etc. The control system generates a steering angle, and acceleration value. End of list. This is how 99% of self-driving cars and autonomous, the four pillars, zoomed in, figure. You are currently in a figure, and a map, and localize ourselves in the world. Bullet planning. From the obstacles around, and from our position, we plan a trajectory from A to B. Bullet control. Using the trajectory information, and the vehicle parameters, weight, tire size, etc. The control system generates a steering angle, and acceleration value. End of list. This is how 99% of self-driving cars and autonomous, the four pillars, zoomed in, figure. You are currently in a figure, and a map, and localize ourselves in the world. Bullet planning. From the obstacles around, and from our position, we plan a trajectory from A to B. Bullet control. Using the trajectory information, and the vehicle parameters, weight, tire size, etc. The control system generates a steering angle, and acceleration value. End of list. And this is just 99% of self, yet, you may have, and this is just the tip of the iceberg. When you zoom in again, you can see computer vision broken down to pedestrian detection, traffic lights, data management, and planning broken down to path planning, trajectory generation, etc. Yet, you may have learned these four pillars in a different order, or with different names. The first time I learned about the four pillars, prediction was part of the planning step, but then, when I learned it from other sources, it belonged to perception, so I placed it in perception, because it made sense to me. I sometimes learned about three pillars, where localization belonged to perception too, and sometimes, there was no control. So which one is right or wrong? I guess we'll never know, and it also depends on what companies want to implement. The only, real, always here, two steps of perception, see the world, and planning, plan a trajectory. So, let's see some examples. Heading level 3, examples of four pillars architectures. To begin, a warning. The four pillars aren't exactly the same to all autonomous vehicles. In fact, every company has developed its own four pillars, and there's a lot of variation. I sometimes learned about three pillars, where localization belonged to perception, and sometimes, there was no control. Let's first see Waymo, who popularized the four pillars in autonomous vehicles. Heading level 4, Waymo and the absence of localization. A first example we could look at is Waymo. This company is one of the pioneers of self-driving cars. It's highly classical and traditional, and yet, it doesn't follow the four pillars that they invented. Waymo's four pillars are a bit different. It looks like localization is a solved problem. Figure. You are currently in a figure. Waymo's four pillars are a bit different. It looks like localization is a solved problem. End of. This is because Waymo evolved their development process significantly around prediction, with many research papers being published since CVPR 2020 around this topic. In fact, at CVPR 2023, one of the 5 papers Waymo published was called MODA, Motion Forecasting for LiDAR, and another was called Motion Diffuser, which involves using diffusion to predict motions. Heading level 4, Apollo White and the 7 pillars. In China, there's a company named Beta that released an open source software named Apollo. The idea is, if you use the exact sensor configuration they give you, you can download their software components, and have access to fully autonomous vehicle. Because it's all open source, so is their architecture. Here it is. The Apollo Auto Architecture, source, figure. You are currently in a figure. Diffusion to predict motions. Heading level 4, Apollo White and the 7 pillars. In China, there's a company named Beta that released an open source software named Apollo. The idea is, if you use the exact sensor configuration they give you, you can download their software components, and have have access to fully autonomous vehicle. Because it's all open source, so is there the Apollo Auto Architecture, link, source, right parenthesis, end of, notice how they have the 4 main pillars, but 3 others. List 3 items. Bullet map engine, bullet prediction, bullet HMI, human machine interface, end of list. They also have their own ROS middleware, called CyberRT. What's interesting is that this is version 8.0, but version 1.0 worked very differently. It used ROS, and didn't even have a perception system. It was a simple GPS waypoint following for parking lots. The Apollo V1, source, figure. The Apollo V1. You are currently on a selectable text. Link, source, right parenthesis, machine into Apollo V1, source, heading level 4. Does naming matters? You can see how Waymo is focused so much on prediction that it even squeezes the idea of localization. Companies like Zoox follow this pattern. Some other companies like Crusoe. You are currently link, Aurora will be super focused on sensor fusion. You are currently, and therefore, they might have one of their pillar named after it. In reality, this doesn't really matter. What matters is that the 4-pillar architecture, or 3, or 5, or alternate 4, is implementing the modules block by block. A team is working on perception, another on localization, another on planning, another on controls, etc., as if they were independent systems. On the other hand, there are companies who do it all in one. You have the sensor, then one algorithm, and you have your output. These are called the end-to-end drivers. Heading level 2, end-to-end architectures work differently. The main idea is to feed all your inputs to a single algorithm that directly outputs the driving policy. So let's see what it looks like. The end-to-end architecture is much more intimidating. What's inside that box? Figure. The end-to-end architecture is much more intimidating. What's inside that box? End of. The end-to-end architecture is much more intimidating. What's inside that box? Figure. You are currently on a figure. End-to-end architectures work differently. The main idea is to of course, millions of questions raise immediately. What's inside that box? Does it really work? Is it really all deep learning? Shouldn't the output be a bit different? Let's first go back to the roots. Heading level 3, end-to-end creed. The first time this type of architecture became popular, it was in 2016 when NVIDIA released a paper called Link, end-to-end deep learning for self-driving cars. You are currently on a text element. Source, figure, millions of parentheses, source, figure, full stop. The paper was a 9-layer CNN that took one camera image as input and output the steering angle and acceleration. Source, figure, left parenthesis, link, right parenthesis. You are currently on a text element, released a paper called link, end-to-end deep learning. This type of project became insanely popular with students who all started their self-driving car project in the Udacity simulator, including me. 87% heading level 3. Since the NVIDIA paper, a few self-driving car startups, but just a few, have tried the end-to-end approach. Heading level 4, Hawaii. You are currently on a selectable text. Link, described companies like Hawaii started by claiming that the best thing to build was an end-to-end planner. E2E, in case you don't know them, Hawaii is selling a smartphone that can be plugged to your car and make it autonomous using the cameras. The approaches, create a dashboard, Pick started playing audio in a link, described here, period. However, in their E2E planner, rather than outputting an angle and acceleration, they output a trajectory represented by X, Y, and Z coordinates in meters, and is linked to a controller. Hawaii end-to-end planner, figure. Hawaii end-to-end planner. You are currently on a selectable text. End of. Hawaii end-to-end planner. To be clear, this isn't the same end-to-end as I described earlier. It's a hybrid. We still have blocks communicating together, like vision and planning, but the overall thing is trained end-to-end, meaning without much rules in place. Most of the training is done in simulators, and the idea is to then scale the learning to any road. YouTube video player framed. Next, let's see another approach, the Wave. Heading level 4, Wave and end-to-end reinforcement learning. There's a company in London called Wave, and this company creates an end-to-end algorithm based on reinforcement learning. The idea is incredibly complex, yet it can be summarized in one picture. Source, figure. You are currently in a figure. Much rules in place. Most of the training is done in simulators, and the idea is to then scale the learning to any road. YouTube video player framed. Next, let's see another approach, the Wave. Heading level 4, Wave left parenthesis, link, so right parenthesis, end of. The architecture is called MILE, model-based imitation learning, and here, you're looking at two observations O1 and O2, and on. You imagination O3. Which is a future prediction. Each observation is sent to an inference model E, which then goes to 3 models that do observation posterior, labels, and action. I recommend to read the paper link with the image, but the point is, when you train this whole thing on Carla Simulator, it generates this. YouTube video player, incredible, is heading level 3. Is end-to-end really end-to-end? No, in fact, I would say besides the NVIDIA model, they are all hybrid. They all, at some point, open the black box, include rules, break down blocks into smaller blocks, so this means there are actually 3 categories. List 3 items. Bullet 4 pillars. Bullet pure end-to-end. Bullet hybrid. End of list. Today, you will probably see most pure end-to-end approaches are research projects, self-racing cars, lane-following robots, etc. But I suspect the goal of hybrid E2E companies is to transition to pure E2E. On the other hand, any automated driving system, or robot, or something with multiple sensors will go 4 pillars. Heading level 2, conclusion, end-to-end versus 4 pillars. Back when I started Think Autonomous, which teaches engineers how to build skills in self-driving cars and autonomous tech, I was told I should start a podcast. I was then told I should create a course on Udemy. I was also told to start a YouTube channel, to keep a self-driving car job, and to use TikTok. I did none of those things. Instead, I started a daily newsletter that is today read by over 10,000 people every day, and I later added a blog. I could easily have transitioned at the start, but I didn't. Instead, I made the email newsletter approach work. You pick an approach, and you then make it work. Take for example Tesla and LiDARs. Originally, Tesla started by being against the use of LiDARs in autonomous driving. It was very hard to implement a computer vision only approach, but instead of going back, they made it work. How to know which one to pick? There are a few rules you can follow. List 4 items. Bullet if you don't have access to big simulation, go with the 4 pillars. Bullet if your products are made for environments where the clients want tons of robustness, safety, go with 4 pillars. Bullet if your team has more expertise in sensor fusion, LiDARs, and free of traditional controllers, go with 4 pillars. Bullet if your team doesn't involve many researchers, and it would be easier for you to use a predefined path, go with 4 pillars. End of list. On the other hand, if you list 3 items, who would have access to abundant data, processing power, or simulation, who would have many deep learning researchers in the team, who are a bit of a contrarian, and are looking for a way to stand out. End of list. Then you could always explore end-to-end approaches. So, now let's do a summary. Heading level 2. Summary and next steps. List 6 items. Board when building and self-driving car software architecture, there are usually 2 approaches to use. The 4 pillars and end-to-end. 1 of 6. Board the 4 pillars of autonomous vehicles are assistant, localization, planning, and control. It all starts with perception, which is about seeing, and the data is then passed to localization, to trajectory planning, and finally to controllers. Board some vehicle manufacturers and startups will invent their own 4 pillars based on where they put their focus, like Waymo and prediction. However, it's all the same idea, with blocks communicating with each other. End-to-end learning is about feeding input data to a model that directly outputs a driving policy, 3D trajectory, or a duo throttle/steering angle. The approach was pioneered by NVIDIA in 2016. Both companies like Wave or Blink, Hawaii, work heavily on end-to-end planning, and both approaches currently work, but being somewhat hybrid. Board if you're hesitating between which approach to build, go with 4 pillars. If you know, you know. End of list. Heading level 3. Next steps. You are currently on a heading level 3. Box 3023 profile.